Hey guys, welcome back to General Chemistry. Today we're going to talk about something called molar mass. So in the previous video, we talked about how to get from moles to things. So moles to atoms, moles to particles, moles to molecules. But the problem is we really don't have any way to count individual atoms. So I can't put a sample of something on a scale and it says, oh, there's X number of atoms. Nor can I really put a sample on the scale and say, oh, well, there's this many moles of that substance on my scale. So it's just not something that we can measure in the laboratory. So let's think about some of the things that we can measure. So we've got pH probe here. You'll get to that in general chemistry too. Here we've got graduated cylinders, so those can measure volume. That will be helpful later on. But the one we're going to focus on is this guy here, the scale. So I can put something on this scale and it'll tell me exactly how many grams of that substance I have. So wouldn't it be kind of handy to be able to go from grams to like moles, or ultimately get from grams to numbers of atoms? That might be helpful, right? Something I can actually measure in the lab and then be able to calculate other things that I want to know. Well, it turns out we do have a connection. This statement is a very heavy, sciencey, thick statement, so I'm going to read it, then we're going to break it down. So, molar mass. The atomic mass in AMU of an element is numerically equal to the mass in grams of 1 mole of that element. Okay? Lots of stuff going on there. So, the atomic mass of an element. Well, where do we find the atomic mass of an element? We look at your periodic table. On your periodic table, that number at the very bottom is the atomic mass. Okay, so for example, sodium, if I go to the periodic table and I look at sodium, the number at the very bottom of sodium reads 22.990 on the periodic table I'm looking at. Okay, so that's the atomic mass. What it's saying is that number is numerically equal to the mass in grams. So all we're doing here is just a unit flip. So I see that sodium is 22.990. I'm going to say, well, that's now 22.990 grams. And that number is equal to 1 mole of that element. So let me say this a slightly different way. I want to weigh out 1 mole of sodium. I'm going to walk over to the scale. I'm going to weigh out 22.99 grams of sodium. And I have just weighed out 1 mole of sodium. So the number on the periodic table is equal to the mass of 1 mole of that substance in grams. So what if I wanted to weigh out 1 mole of carbon? How much would I weigh out? Go to the periodic table, find carbon, and we see that it's 12.011. So I'd weigh out 12.011 grams. If I wanted to weigh out 1 mole of iron, how much would I weigh out? Go to the periodic table, I look for iron, I see that it's 55.845, so I would weigh out 55.845 grams of iron, and I have just weighed out 1 mole of iron. So that's what the molar mass is. We can use this information then to write an equality. So we've talked about equalities already. Equalities are just values that get us from one unit to the other. So the new equality that we have is 1 mole equals X number of grams. Little twist here, right? The X in there. So why is there an X? Why is it X number of grams? Well, it depends on the substance that we're dealing with. So if the substance is sodium, that number is going to be 22.990. If that substance is nickel, it's going to be 58.693. If that substance is fluorine, it's going to be 18.998. So the X just tells us that it depends on what it is we're dealing with, and the problem will tell us what to use there. We, of course, then can use these equalities in a conversion factor, stacking one on top of the other, and depending on what the problem wants us to do, that's the conversion factor we use. So let's take a look at an example of this new equality. So according to nutritional guidelines from the U.S. Department of Agriculture, the estimated average requirement for dietary potassium is 4.7 grams. What is the estimated average requirement of potassium in moles? So this very lengthy problem is asking us one thing. What is 4.7 grams equal to in moles? We're going from grams to moles. So we're going to set up this unit conversion like every unit conversion we've ever done and will ever do. We're going to start with the information that's given. So the first thing I'm going to write down is 4.7 grams of potassium. I make my train tracks. With little to no thought, I wrote grams of potassium on the top. I'm going to rewrite grams of potassium on the bottom. Okay, so that's the unit I'm trying to get rid of. What's my destination in this example? So it's asking us to calculate moles. So the unit that's going to go on the top is the unit of mole. Okay. Let's go back to our equality here. First, what number is attached to mole? Yeah, the number 1 is attached to mole. And that's going to be true for every problem we see for a while, probably until about test 3, will we hold on to the number 1 will always be attached with mole. Okay. So I see my unit mole on top. I'm going to put a number 1 up there. Now for grams, what number is attached to grams? Well, here's where we have to go to the periodic table. The substance that we're dealing with is potassium. So I'm going to go to the periodic table. I'm going to find potassium on the periodic table. And I'm going to see that the atomic mass is 39.098. Where did I get that number? I got it from right here on the periodic table. So just copy that into my problem. All right, to solve this, we're going to multiply across the top, divide by the bottom. So I'm going to take 4.7 times 1 divided by 39.098, and my calculator spits out the following value. Sig figs, you have to think about sig figs, right? So we have to look back at the measurement that was taken. The measurement that was taken was 4.7. That has 2 sig figs. So when I report my value, I can only report 0.12. And then looking at my units, grams of potassium cancel, and we're left with moles of potassium. So again, just doing a simple unit conversion, using our new equality, 1 mole equals X number of grams, and that X will come from the periodic table. If you guys want to work some problems, the next slide does have a couple examples with the answer built in, so you can challenge yourself and then check your answer. I hope you guys found this helpful.